Class, we looked at graphing linear inequalities. It is very, very similar to graphing linear equations, just like what we did in our unit before this last one. We're only introducing inequalities. Now, inequalities, you might not remember what they are. They are those alligator symbols. So we have greater than, less than, greater than or equal to, or less than or equal to. So we're going to label them as is. So this is greater than. This one is less than, greater than or equal, less than or equal. So these inequalities are more about, instead of finding one particular perfect answer, they're finding a range of answers. So if I told you that in order to get a 3 on your work habits, you needed to get 40 minutes of iReady, you had to get 40 or more, we would use the greater than. Not exactly 40, but anything above 40. If I told you that in order to not strike out in baseball, you had to get less than 3 strikes. After 3, it wouldn't make sense. I know you can't get 4 strikes, but that's the whole thing. You can get 1 strike, you can get 2 strikes, but you can't get 3 strikes. It has to be less than that. So inequalities are all about range. So when you have a statement like this, x is less than 3, in order to illustrate all of the possible answers that x could be, we use a number line. The number right here represents one of the boundary points, and then one other point on this number line to help us understand which direction it goes. I always pick 0 if this isn't 0. So I need to have all of my x's that are less than 3. So actually, I'm going to, because the way I have it written basically gives away the answer. So say it's like this. So 3 is that dividing point. So right here, I'm going to put a circle at 3. So my answers are either on the left-hand side or the right-hand side of this circle. This circle is classified as an open circle because I can't have exactly 3. It has to be less than. Can't be equal to. So if this was an equal to, I would fill in this circle. So now I'm going to figure out where do all of my answers lie. So numbers that are less than 3 are over here. So we draw an arrow that covers up or points towards all of the potential answers. So 2 is an answer, 1 is an answer. 1.5 is an answer. 2.9 is an answer. But 3.1 is not. It's on the wrong side of our circle. So what we're going to do today is we're actually going to be graphing 2 variable inequalities. So a lot like the lines we've graphed before, they're going to include all of these components. So should it be an open or closed circle, and which way will our answers exist? So help us with our first one. Let's graph the line y is greater than 1. We're going to graph this line exactly how we would graph y is equal to 1. So y is equal to 1 is a perfectly flat line right here at 1. Perfectly flat right here at 1. But this symbol right here asks us, should I draw a dotted line or a solid line? Is 1 included in our answers? Can I pick 1? Because it's just less than, means we draw a dotted line. So right here at 1, I have a dotted line. Right here. So I'm not allowed to pick exactly 1, but I can pick numbers on either side. What we're going to do now is we're going to try to find where all of the potential answers are. So y has to be greater than 1. We're going to pick a point. Easiest point to pick would be 0, 0, our origin, as long as that point isn't already on the line. If it's already on the line, you have to pick something else. It's not on the line, so we're going to choose it. In this particular case, I don't need to worry about plugging in for x because there isn't one. So I'm going to plug 0 in for y. So I get this statement. 0 is greater than 1. I ponder this question for a second, and I go, is 0 greater than 1? And the answer is no, it's not. That makes this point false. That means everything below this line is not a valid answer, meaning I have to shade above this line. What this statement is saying is that above this blue line, all of our y values are bigger than 1. To prove it, we can plot a point anywhere we want that's inside the shaded region. Boop. Let's say right there. The y-coordinate of that point is 4. It is, in this case, 1, 4. The 4 is larger than the 1. I can move that smiley face somewhere else. Still bigger than 1, still bigger than 1, still bigger than 1, still bigger than 1. The minute I drop the smiley face over here out of the shaded region, that's when my y value is not larger than this 1 anymore. So what we're going to do is we're going to graph some of these lines like we did in our previous unit. Say we've got y is less than or equal to negative 2x plus 3. So just as it was a slope-intercept form, we're going to start up here at 3, down to right 1, down to right 1, down to right 1, down to right 1, up to left 1. We take a look at this symbol right here. Because it's an equal to, that makes this a solid line. Now we got to figure out where are all of our other potential answers. Where does this actually work? We get to pick any point on the graph as long as it's not on the line. 0, 0 is always the best choice just because it's the simplest. So I'm going to take 0, 0, 0 for x, 0 for y. So 0 for y is less than or equal to negative 2 times 0 plus 3. I'm going to go through and simplify this statement. At the very end, I'm going to see if this statement makes sense. Is 0 less than or equal to 3? The answer is yes. Makes this point true. Because it's true, we get to shade in this direction. You might be thinking right now, well, what if it was false? Just like the last example, if we had found out that this wasn't true, you shade the other way. That's why it's just good to pick any point. So if I were to plug in this point right here, that's 4, 1. I plug that in, so that's 1 is less than negative 2 times 4 plus 3. So that's 1 is less than or equal to negative 8 plus 3. So 1 is less than or equal to negative 5. That doesn't work. That point is not a solution. I'm not allowed to shade anywhere near it. So if this line is the dividing line, you don't want to be on the loser side, you want to be on the winner side, which is the other side. We also looked at systems of these linear inequalities, and that just means we're going to graph two lines, and we're going to see where the shadings overlap. So maybe I've got y is less than 1/2 x minus 1, and I've got y is greater than or equal to negative 3x plus 4. So I'm going to graph this first one in red. I start down 1. Then I go up 1, right 2, up 1, right 2, up 1, right 2. Before I draw the line, I'm going to decide dotted or solid. Because of the lesson, it's just dotted. I get to pick any point that's not on the line, so 0, 0 is still an option. So 0 is less than, the 0 causes that to disappear, negative 1. So 0 is not less than negative 1. So this is false, so I would end up shading below. Because I'm going to end up shading 2 different lines, and I don't want it to get too cluttered, what I do is I draw lines like this to remind me which way I'm supposed to shade this line. Once we have the other line on the page, we can shade the common region. I'm going to graph this one blue. So we start up 4, 1, 2, 3, 4. Down 3, right 1. Down 3, right 1. Down 3, right 1. It needs to be a solid line. Zero, 0 is still not on its line. So I could plug 0 in for y, which means 0 goes in for x that causes that to disappear. And I have 4. So is 0 greater than 4? That's also false. So I don't get to shade towards this dot at all. I have to be shading them away. And if we were to have this perfectly shaded, the places where it would overlap is right here in this purple region, because red and blue make purple. So anywhere in this purple region, you would have a point that satisfies both of these conditions. Meaning, I pick a point inside this spot right here, say right there. That point works in both the first and the second equation. It's like, I need you to give me a number that's bigger than 5, but is also even. So picking a number bigger than 5 would be like this top one up here. And this one would check if it was even. So you're like, I picked 6. Bigger than 5 and even. If you're like, 7. Well, that's bigger than 5, but unfortunately not even. You can't fail one and get the other. It needs to satisfy both. That's this area. So again, kind of that last part I might have confused you a bit. So if I were to pick a point right here, that would satisfy the conditions for our first line, but not our second. If I picked a point right here, that would satisfy the conditions for our second line, but not our first. So we want both of them right there. You also have to graph it with standard form, so I'm going to practice an example like that. Say 3x plus 4y is less than or equal to 8, and then 2x minus 4y is greater than or equal to negative 8. Okay? With standard form, we always graph it with our table. So we're going to do 0 for x, 0 for y. We're going to do this twice. We're going to treat this inequality symbol as an equal sign as we do this process. So we don't have to worry about less than or equal to or such. So 0 goes in for x. So these get covered up. 8 divided by that 4 gives us a y of 2. For our second equation, y is also 2. So funny enough, I'm going to graph this first one green. The second one will be purple. Both of them have a dot right here. We plug 0 in for the y's. Eight gets divided by the 3, so we get 8/3. So that's 2 2/3, so that's 2.6. That puts us at right about here. And on the bottom, we divide -8 by 2 and gets -4. So that point is right here. Looking at our green line, green, it needs to be solid because it's equal to. So drawing it as best as I can. There's our line. The other one also has to be solid. So right there. Lucky for us, 0 is not on either line, so we're going to check it with 0, 0. So looking at our first equation, 0 goes in for x, 0 goes in for y, so we get 0 is less than or equal to 8. Well, that's true. Meaning for our green line, we have to shade towards 0, 0. So we're going to be shading everything below. We plug 0, 0 in for our second equation. 0, that becomes 0, so it's 0 is greater than -8. Well, that's also true. So we have to shade towards 0, 0 for the purple line as well. So where do the two shaded regions overlap? Right here. And that's graphing systems of linear inequalities.